Hello everyone, welcome to a video on Nix programming. I actually don't know what video number this is, maybe it's 7. And we're going to cover derivations today at the very least. In the previous video we talked about impurities. Well, my memory is fully gone. So impurities we talked about, I don't remember what they are anymore. Let's take a quick look to remind ourselves. All right, getting paths and fetching stuff, all the things that basically could be changing that aren't pure functions because it interacts with your system or the outside world sometime, like getting time or whatever. All right, derivations, let's get at it. So if you're new, the idea here is that I'm learning Nix, the programming language, and also probably how to use Nix in general. I think that's where this is headed. And if you are following along in the videos, then you'll be learning Nix also. We're using the public Nix documentation. So if you look in the description, you'll have a link to where we're looking at it to start with derivations. If you have any questions, just come on the Discord channel that's in the description, and I'm happy, or others are happy to help you. Okay, let's get at it. Derivations. Derivations are at the core of both Nix and the Nix language. The Nix language is used to describe derivations. Nix runs derivations to produce build results. Okay, so we run derivations. Build results can in turn be used as inputs to other derivations. So I guess it's like it can go in a cycle where these derivations, we're describing it in the language, right, with functions and impurities or whatever. And then it produces a result, which will be probably files and stuff. And then you can have other derivations that take this new file that was produced and make new things from it. So kind of makes sense. The Nix language primitive to declare a derivation is the built-in impure function derivation. So we learned about impurities here, but it does say derivation. In practice, describing derivations requires observing the outside world. We will discuss derivations. Oh no, it says this only because I added it to, I made an edit to their documentation and submitted it, and I'm just surprised to see that it's already live. Okay, it is usually wrapped by the Nix package's build mechanism, standard environment, make derivation, which hides much of the complexity involved in non-trivial build procedures. You will probably never encounter derivation in practice, so it won't see this. But let's make sure that it really exists. So let's do Nix REPL. And what was built-ins was like built-ins like this, right? I can't remember. I think so. And then they said derivation. So this should give us a lambda or something like that. Yep. So it's a function. And there should be something called standard environment, I think, dot make derivation. Okay, so I don't know how to use this, I guess. We'll find out more about this in a bit. Whenever you encounter make derivation, it denotes something that Nix will eventually build. Example, a package using make derivation. Let's click on see what this is. So here we have this is a function, right? Because this is the head of the function where we're describing the parameter it's getting. The parameter is an attribute set with these things as names. And then the function calls standard environment make derivation, and we pass in an attribute set, but it's recursive, so that you remember what that meant. Like that means that one of your key values can actually refer to another one. in the values. P-name, package name, version, where the source is. We're getting the URL, it looks like. Fetch URL is a function. And meta with lib. So under lib we have licenses GPL3 plus. Okay. So we don't really know exactly what it does yet though, but we'll get to it, I'm sure. The evaluation of such derivation and make derivation is an attribute set with a certain structure and a special property. It can be used in string interpolation, and in that case, evaluates to the Nix store path of its build result. So I'm a little confused here because they say example, right? And so like I'm looking at the example and I'm looking for a derivation or a make derivation, but I don't see these words here, right? And I'm guessing it's because, remember, import actually brings the file contents in and evaluates it. And Nix packages here probably is a function that uses derivation. But we don't see that in the code, so I don't love this example. I would rather see something where we're actually calling make derivation or derivation. But we've seen this before, where basically anytime you pull in a function and then you evaluate it because we're passing in the empty set, this is going to return you the attribute set. And they said that here, right? Attribute set. And on its own, like we can do that again up here. Let's, what do they do here? Packages is equal to import Nix packages. We pass in an argument, semicolon to close, and then we just like, if we just do this, it will be, this will be the function. I don't know if we can, it'll allow us to print that. Let's see. Nix instantiate, I forgot the name. Minus eval minus, well, it won't pass in strict. It's going to use default.nix by default. Oh crap. Yeah, so this is a big function, I guess. Or no, so since we evaluate it, it returns an attribute set. And because it's in an attribute set, it wants to print it all out, and packages is all of Nix package definition, so that's not good. But if we just print out the function, it'll just say lambda. And then what I was trying to remember to get back to was if we pass in string interpolation here of the actual attribute set, it will, what this is telling us is it will tell us where it is in the store. Ay. Packages, what am I doing wrong? Let packages equal import Nix packages in packages. Oh, because you can't print out, cannot coerce a set into a string. Okay, so we need to give it a specific package we're looking for. And it tells us where it is. Oh, okay, so we did learn something. I didn't realize this is what they were talking about, because I thought they were just doing packages like this and it would just tell us where it is. But no, you tell it specifically the package name, and because I know I use Helix. This is the editor you see. So let's see. Oh, that's so cool. So now if I look under Helix, I should see the editor that I'm using. There's my editor. Oh, because I'm not using my Nix shell. There we go. It doesn't have it. I want to evaluate this again. Nix instantiate eval, and it's the same directory. How cool is that? Sorry, it just makes me happy when these things start to make sense and work. You get to be like, oh, I'm starting to understand what this is. All right, perfect. Your output may differ. It may produce a different hash or even a different package version. A derivation's output path is fully determined by its input, which in this case comes from some version of Nix packages, right? Because all we say here is Nix packages. We didn't give it like the very specific version of Nix packages that we want. This is why we recommend to avoid lookup paths to ensure predictable outcomes, except in examples intended for illustration only. So it's saying don't use Nix packages like this. Always use a specific one. We're going to see that again later. In the example, imports the Nix expression from the lookup path Nix packages and applies the resulting function to an empty attribute set. Its output is assigned the name packages. This is exactly what I said earlier. And it is an attribute set. Converting the attribute Nix packages.nix to a string with string interpolation is allowed, as Nix packages.nix is a derivation. That is, ultimately, packages.nix boils down to a call to derivation. Okay, so packages.nix calls a derivation. But you see where they told us this here, it doesn't explain that here. So we're like, well, how is this an example of derivations? The resulting string is the file system path where the build result of that derivation will end up. There is more depth to the inner workings of derivations, but at this point it should be enough to know that such expressions evaluate to Nix store paths. Okay. So this is key, I guess, like when we convert it to a string, then these things happen. I think we talked about that earlier. It's going to tell us where it is in the Nix store, which is where all this stuff goes in your local system. String interpolation on derivations is used to refer to their build results as a file system paths. As file system paths when declaring new derivations. Okay, this allows constructing arbitrarily complex compositions of derivations with the Nix language. So you use the string interpolation because you want the results of whatever you just did, and then you can pass along that file to another derivation. So far, we have seen artificial examples illustrating the various constructs in the Nix language. Oh, okay, so we're in a new section. We're done with derivation. So we're looking at worked examples now. You should now be able to read Nix language code for simple packages and configurations. Yay! This is a milestone. And come up with similar explanations of the following practical examples. Note, the goal of the following exercise is not to understand what the code means or how it works. That drives me crazy, right? It's like, don't try to figure it out. That's what I do. I like to try to figure it out. But how it is structured in terms of functions, attribute sets, and other Nix language data types. Okay, let's take a look. You do this yourself too. Let's try to figure out what this means. So what are we looking at here? We're looking at a function, right? Because this is the attribute set parameter that it's taking. And this is the body. So we're getting the Nix packages from here. I don't think we learned what the question mark means. Maybe it means like, it looks like the functional if. Maybe it means like it's grabbing if packages doesn't exist already, but like a default value or something. Anyway, um, let message equals hello world in. So this is where this is the scoped variable message that we're setting to hello world. And then we're going to do this. Packages make shell no cc. No what? Like compiler? Maybe C compiler? Packages equals with packages cause. So that means this becomes packages.cause, right? We looked at that before where we learned about with. Where was that? With. Yeah, so when you have with A, then all of these is going to be in the scope of A, so it'll be A.x, A.y, A.z. So let's go back to what we're looking at. So when it says with packages, this means packages.cause. It's kind of like, well, why all this extra typing? It's probably just idiomatic. Shell hook equals, and then the two quotation marks, single quotation mark means a multiple line string. Cause, and then the message. So message is over here. It's going to use that as for string interpolation, and it's going to say cause message. All right, sounds good. So make shell. So I'm guessing that like this is going to spawn a shell, and then it's going to execute cause hello world as a shell command. So you'll see the results of that on the screen. And it's going to grab cause the package if you don't have that already. All right, let's go see if we were halfway right. This example declares a shell environment. That's the hint, right? Which runs the shell hook on initialization, right? So it's going to run this shell hook. This expression is a function. That's what we said early on. Here's the function. This part, the colon here makes it clear it's a function that takes an attribute set as an argument. Perfect. If the argument has the attribute packages, it will be used in the function body. Otherwise, by default, import the Nix expression in the file found in the lookup path Nix packages, which is a function in this case. Call the function with an empty attribute set and use the resulting value. Okay, that makes sense. So when we use this function, if we already passed in packages, maybe we give it a different package, which would probably be like a specific version of a package of Nix packages. But if we don't, then we just use this one for default. I was close, or maybe even right. I don't remember. The name message is bound to the string value hello world. We called it variable, but that's just probably a bad habit of mine. I should call it name. The attribute make shell no cc of the packages set is a function that is passed as an attribute set as argument. Okay, let's try to break that down. The attribute make shell no cc of the packages set. Right, that's because here, this is packages. We got that from this packages up here. And this is one of the values inside of it. It'll look like packages, and it'll have like make shell no cc equals something else. Is a function that is passed as an attribute set as an argument. Is a function. So it's telling us that this is a function. And I guess like we should just check that out, right? Like we should be able to do, let me just use NixRepl. We should be able to do import, no, let me do it up here because it's a little easier. Packages equals, and then we do packages dot, what is it, make shell no cc, right? Function args. Oh, it looks like it returns an attribute set. That's really interesting. No. Yeah, it returns an attribute set. And it has a name, function args, and then it has this stuff, which is another attribute set. Build inputs, these are all like things that are passed into function args. And then we have something called functor. So here is another name called functor, and it evaluates to a function. And then we have override. And then we have another function. Okay, so this thing is an attribute set, and within its attribute set are some things that are functions. Let's see if we can read this again. The attribute set is a function that is passed as an attribute set as argument. Okay, no, I give up on that sentence. I don't know what it means. Oh, I do know what it means. Set is a function that is passed an attribute set as argument because it's saying this is a function and it's being passed this as an attribute set. All right, sorry guys, that was obvious to you all. But what I don't understand now is how come when I evaluate this, it looks like an attribute set and not a function. So when they say it's a function, it doesn't look like a function to me. It's just weird, right? I don't actually know what that would do, but oh. Cannot coerce a set to a string. So even here it says it's an attribute set. I don't understand. Anyway, let's go on. The attribute set passed to make shell no cc. Oh, just to make sure I explained like how to parse this sentence in case anyone else was confused. So the attribute make shell no cc of the packages set is a function. So you're saying, hey, this is a function. I'm telling you this is a function. And this function in this context is being passed an attribute set as an argument. So here's the attribute set. We're passing it as an argument. So it's going to apply this argument to the function. Does that make sense? Its return value is also the result of the outer function. Yeah, so it's, I mean this function, make shell no cc. The attribute passed to make shell no cc has the attributes packages, that's here, set to a list with one element, the cowsay attribute from packages. Yep, this one item in this list. And shell hook set to an indented string. The indented string contains an interpolated expression which will expand the value of message to yield hello world. All right, so let's try running this. So we have packages here. And we don't need that, right? It needs to be a function. I don't actually know what's gonna, like, how do I even run this? Do I just make this default.nix and run this? Let's see. So this thing takes in packages, and we say default to import Nix packages, and we give it the empty attribute set by default. This is a function, so we need the colon, and then in here we make message equals hello world, and then in here what do? We have to define packages dot mk shell no cc, I think it is. This is a function, and we're going to call we're going to pass it an attribute set. Inside the attribute set is something called packages equals with packages. I think we need a list here, a single list with, what's it called? Say. Right? Yeah. So it's expecting packages, in case that's not clear. We're not making that up. It needs to be called packages. And then shell hook is equal to, we give it an indented string, and it's called say, so it's the thing we have installed, and then the interpolated string of message, and I think that's it. Right? All right, so let's evaluate this, see what happens. What did I do wrong? I probably don't have the right matching. What? Syntax error, unexpected. Why did I put braces in there? Are you guys like wondering also? Yeah, with packages, and then you give it a list, and inside of all of these, it's as if I typed packages.calsay, right? Okay. Lambda. Great. Lambda. How do I execute this thing now? No, I don't know. So one of the problems is, so this thing works, but like I don't actually know how to use it yet. I'm jumping ahead. Remember, this was just to like try to figure out, can we understand the program not to be able to do it, as they said. All right, next one, NixOS configuration. So this is a function again, because you see this is the parameter it's taking, which is an attribute set, and it has names called config and packages, and accepts additional names that aren't necessarily config or packages. And the function returns an attribute set, because this is an attribute set. I was kind of expecting like a let or something else, but no, it's just an attribute set. I don't think we've tried functions like this. Like, just to show an example, like most of what we've written looks like this, right? But let's do another one where we're like, here's my function. It's like foo, and it returns A equals B. No. Like this. This doesn't kind of make sense, right? But if I should save this. I think I have caps lock on. Right, and we call cons.nix. Alright, so how do I execute this? Well, I guess for me, I have to put it in a let. Here's the function. And then the function can take a foo. Let's make foo 300. Since it's a let, it's an assignment, I need a semicolon at the end. You see, like, what's weird about this function is that even though it took in a foo, it doesn't use it, right? So that's kind of like, not only does it not use it, but it doesn't have anything after. It's not like there's a let or anything, a keyword. It just returns an attribute set. And that's what this thing is doing. Just if you just take away this, you know, everything in the let part. It's returning an attribute set. And in the attribute set, it has imports. And this is a list of file paths. Remember, Nix impurities is file paths. You can look at that video. Environment.system packages. So this is making a new name called environment, and that is an attribute set itself, which has a sub key called system packages. All right, does that make sense? Because this is like saying when we have something like environment and you do system packages equals something, right? Like, let's say we just made it 3. That's the same as saying environment is equal to, and then you make a new one, system packages. Right? Does that make sense? That's what's going on here. And with packages, so we're using packages that came from up here, and we're doing packages.get. All right, perfect. So I think we figured that out. This example is part of a NixOS configuration. That's cool. This expression is a function that takes an attribute set as an argument. That's this. It returns an attribute set, right? That's what we said. That's this. The argument must at least have the attributes config and packages. Yep. And may have more attributes. That's the 3 dots, the ellipses. The returned attribute set contains the attributes import and environment. Imports is a list with one element. Yep. It has this path. A path to a file next to this Nix file called hardware configuration Nix. Okay, got it. So it's wherever this file is, this function derivation or whatever we're calling it, in that directory, because the dot means current directory, and then it's getting this file there. The returned attribute set, yeah. Note, imports is not an impure built-in, is not the impure built-in import, but a regular attribute name, right? Don't confuse this with the function built-ins dot just import without the s, which actually brings in the file. Environment is itself an attribute set, that's what we said, with one attribute, system packages. Yep, this environment is its own attribute set with one with another attribute set in it with one name, system packages, which will evaluate to a list with one element, the get attribute from the packages set. Yes, so we're going into packages and we're getting the get element. The config argument is not used, meaning this. So maybe like that's what this is, the comment code, commented out code, and it means probably it's using the config. All right. Wow. Guys, look. We're like literally almost done. All right. Package. I'm terrible at drinking coffee when I'm doing these. Somebody wrote a comment saying that they really like the videos, that it's like slow, detailed responses with like asterisks around slow. And I think they really appreciated it. They already know Nick, so it actually doesn't really help them much. But I thought, it's like, oh, am I going really way too slow? I think when I've helped people with coding before, they're just like, can I get on with it? Can I just move on? It's like, no, it's important to really understand what's going on. So I can only imagine on video number 7 here, the only people actually looking at it who've actually made it this far, even in this video, because it's probably like been 20, 30 minutes now, are people like me, I guess, who actually really liked kind of delve into things. Anyway, yeah, let me know in the comments. As of this time, I've made 7 videos or 6, and no one has made a single comment. So, I don't know. I'm learning this. I'm happy because I'm learning this, right? So, I hope it's useful to someone else. All right, package. Here, it's a function. Wow, so surprising. And it takes in an attribute set with names, lib, standard environment, fetch URL. It calls this function make derivation. You know, when I was doing the make derivation before and I was confused, it was returning an attribute set. Maybe it was just because it was evaluating the function, right? And the function is returning the attribute set. Maybe I was just like totally crazy. Anyway, so I have faith that this is a function, and it's being passed in an attribute set that is recursively defined. Pname, version, source. Source calls fetch URL. That's in here. It must be a function because of the format here, right? It's like something function, and here's the parameter. So fetch URL is a function, and we're passing it an attribute set that has an URL, English, a URL, and also the SHA-256. It's probably going to fetch, what it does is probably fetches this and then make sure that the SHA matches. All right. And then whatever that function is, it returns that value in source. We don't know really what it returns, but it could be like a directory. It could be like the actual contents of that URL. Meta with lib. So all day today, there's been a sound I don't know if you heard that, in this room, and it's like something moving. And I thought I was like imagining it, but I just heard it. Maybe I can make this a TikTok, like just this part, right? Like, what is that? Maybe you guys even see it and I didn't see it. But it's like something scuttering or moving. Maybe it's a mouse. That would be terrible. But why doesn't it move more? This makes sense. Anyway, if you ignore it, it doesn't exist. With lib, which means in here, everything's under the lib context. So it's funny because when we saw with last time, it was it was with a list, right? And here we're passing it an attribute set. So let's look at that. With, and we have a list. With, we have a list. With, we have a list. It doesn't tell us like how that works in an attribute set. But my guess is it doesn't make any sense to put lib in front of the license because we're making the name. So here it probably means lib licenses GPL3 plus. Hopefully we'll learn that when in the explanation. All right. Let's go into this. But like what's also weird for me here, pname. Oh, this is why it's a rec, you see? Because it's using string interpolation to access another name in here. And normally you can't do that with a normal attribute set. But since we're a recursively defined one, we can refer to other attributes within our attributes. Okay, now I understand why it is a rec. Probably they don't make everything recs because recs are probably slower in terms of like how they're constructed in memory and accessed. All right, let's look at it. This example is a simplified package declaration from Nix packages. Didn't we look at something like this? What was this at first? Oh, it's a shell environment. All right. This expression is a function that takes an attribute set which must have exactly the attributes lib, standard environment, and fetch URL. Yeah, because what do you need to make this take in optional attributes? You need the ellipses. It returns the result of evaluating the function makeDerivation. There we go. Which is an attribute of standard environment. Yes, it's in standard environment. Applied to a recursive set. Oh, that's what we should call it. Recursive set. The recursive set passed to makeDerivation uses its own pname and version attributes in the argument to the function fetchURL. Oh, I didn't even notice it passed in version here. FetchURL itself comes from the outer function's arguments. Ah, yeah, this is what it means. Outer function. I guess this is the outer function. The meta attribute is itself an attribute set. Yes, because it's an attribute set here, where the license attribute has the value that was assigned to the nested attribute lib licenses GPL3 plus. Right, so lib licenses. So that's cool. I guess just for experimentation, we like to do it. So we should test out the width. So we do something like we have a name and then inside of it, and now we do something like my name is equal to wait. No, let's just make it up here. With name, and then in here we do a is equal to name, right? Is that how it would work? Yeah. So with name a equals to name. No, that's not how it works because the width needs to be an attribute set. right. With names, and then we do, it's going to be names dot name one. What? With names semicolon. Uh, my name equals, what is a syntax error, unexpected equal. Why didn't it like that? Oh, right, because guys, you see, like, what's going on? I am trying to assign a variable in the end that's supposed to be up here, right? So you can't do that. You can't do like foo equals bar over here. That's what you have the top part for. So with names just means I'm going to be using the names here, and I'm going to be returning an attribute set that has a in it. All right. Too many. What did not like? There we go. This is why it's good to try, because you think you know it. Like, I was convinced, I know this. I could do it. I know how to make this example. And like I try, I'm like, what? Like the brain just stops braining. Please do these exercises. All right. So we've shown that we can use with an attribute set and not just a list. Okay. Wait, are we done? Holy shit. We're done. We're in references now. Next step. I feels like I read get good. Like, next steps, get good. Like, click on the head. Just get good. If you want to take a longer break from learning Nix, you can remove the unused build results from the Nix store with. I have literally like 400,000 unread emails. I'm not going to garbage collect like four different packages that Nix just installed on my hard drive, you know? All right. I really don't know what we're going to be doing next. I mean, obviously we learned how to program some of this stuff, but like we can't make, like, I don't know how to make these derivations yet. So I would say we kind of know the basic language now, but we kind of have to figure out how to use it. I'm not sure, so let's see here. Get things done. Declarative shell environments with Nix shell. It wasn't this like, this was like really high up before even learning the language. So we probably, but now we know how to read these things, right? Whereas before we didn't. So why don't we go back to this next time and see what we can learn from it. But yeah, I want to start being able to use at least Nix shells and find out what else we can do with it. All right, great. Thanks so much, everyone. Thanks for sticking around. Please give it a like and subscribe if you've enjoyed it. Leave comments, join the Discord server, ask questions. I also want to start another video series on something else. I've been playing with like ideas of either like, I don't know anything about Godot, the game engine. And I was thinking like maybe I should learn Godot, like scripting Godot, much more on the programming Godot than on any like making graphics or 3D objects. Um, I was thinking like, I don't know why, but I went down a COBOL rabbit hole. Like you read these stories about like people getting great jobs doing COBOL, and they're like tired of it because I don't know if you watch Victoria Explains, but I like her videos on YouTube, and she quit her COBOL job because she was like, oh, I couldn't like interface with people and like talk with people. And I'm like, that sounds like the perfect job. Like you just sit in the back working on a mainframe. No one understands you, understands what you're doing. So you just get left alone. Sounds perfect. I don't think I really want a COBOL job, but like it got me thinking like, what would learning COBOL be like? And even funnier, like once I went down the rabbit hole, COBOL itself isn't hard to learn, but you don't get a job for knowing COBOL. Like you have to know IBM mainframes. And IBM mainframes, like how do you learn IBM mainframes? There's no mainframe you can just buy, you know? So um, there's some ways to get like a learning account with IBM where you can like play around on a mainframe, or you can get like an old version of an IBM operating system and run it on an emulator uh, on like the MVS operating system, and that will kind of let you learn COBOL on that. The other thing I was thinking is like WebAssembly. Like it's kind of funny to like program WebAssembly like by hand, not like take Rust and program it into WebAssembly, but like directly WebAssembly. That might be fun. And I also was like really playing around with like I never had like an old 8-bit Atari computer, and I'm just curious about it. Like what are these simple computers like to program on? So I was thinking like maybe of just learning how to program assembly on an Atari like 800 XL sort of like computer through an emulator or a real one. Those are just some ideas. Haskell's really high on my list. I love functional programming languages. So Nix is a functional program language, and you know, I think it would be fun. So if any of you have a suggestion or like any of those ideas, please let me know. And hopefully see you soon. Thanks. Bye bye.